Thank you for attending our talk on EmotionFX, the overall workflow. So thank you for attending for our in-person guests as well as our virtual guests. So I'm Alex Damarjian, a technical trainer with the AWS Game Tech team.
This is Roman Hong. I'm also from the AWS Game Tech team. I'm a software engineer, not a PhD.
No, but he is a compendium of EmotionFX technology and knowledge.
Thank you. That's a...
Yeah. So what we're going to do today is essentially this. We're going to create this project together. We're going to drive it using the WASD or WASD keys, and we're going to trigger different movements and blends and all this other good stuff. It's just a little example of what we're going to be covering. The agenda is, and I won't insult your intelligence by reading every one of these bullet points, but we're going to essentially start off with, well, what is the practical application behind using this across a variety of different technologies, all the way up to how do you implement this within O3DE using the input manager, which again uses the keyboard or game controller and all that other good stuff. So let's start with the practical application. So over to the left is my left, essentially on the screen. It's the example of the character that we're going to be using, which is a Mixamo character, to drive it in more of a game-centric way. So this is like jumps, punches, kicks, things like that using keys and stuff. Now to the right is an example of using a similar technology to do something that's in more of a simulation. So this is actually from my doctoral dissertation, it was a game that was used to treat the Detroit Police Department with their PTSD. Now, the reason why this is important or interesting games versus simulations is really when a police officer wears the headset and they're viewing these or experiencing these different animation states, it's really the same exact technology, whether it's games or simulations. So as they speak, it'll trigger an animation and things like this. And a lot of this will make better sense for those of you who don't necessarily have a background in animation or state machines on how all this works. Now, you can download our project files from the following repo. But you don't necessarily even have to go there if you don't want to. You can actually go online to Mixamo and just pull down some of these projects. So what's really nice about O3DE, it's got fairly good compatibility with like whether you want to create your own models or pull them down from Mixamo. So if you click on characters here, you can see there's a ton of characters you can use. As well as if you click search, you can just download the YBot model, which is the one that we're going to be using. And then you can pull down a bunch of animations. So for example, let me refresh this for a second because it looks like the YBot model didn't pop up here. And you can see it says YBot here. So you'll need like a walk, a run, really just a list of different ones. I would suggest a walk, a run, a left turn, and a right turn. So, and what's also nice about this, if you're not familiar with Mixamo, is you have two options. You can create something like this where you can see characters moving along the surface, which is called root motion, which we're going to get into later, or you can have the animation walk or move in place, which is more of a cycled animation state. When I create my own animations, I actually love animating where a character's moving across the surface. It feels a lot more alive. And that actually takes us into our next point, which is, well, if you don't, say you have an animator, a rigger, or a modeler on your team, and you're not using animations that are essentially from Mixamo, or you're not downloading them from a different site. There's a variety of different sites out there where you can get different animations. So I actually have two examples of a sort of a more, an earlier version of doing animations that you'll still find today. So I have friends who work at studios that are actually making games for arcades and almost branching AAA, but they're not using that advanced of a rig. They're using something called a simple rig. And what that is it's just a rig where you have your modeler create the character, and if they're lucky enough to have a character rigger, they'll create the skeleton, which is here, and then they bind that skeleton back to that mesh. And with a simple skeletal system, you're actually setting keys. That's these little red markers, and you're just moving it right on the rig. So you might be wondering, well, okay, so if that's a simple one, so what would be a more advanced rig? So here's another character model that I made with a little bit more of an advanced rig, and you'll notice that it has these little circles here, or they're called controllers. In Maya, they're used by creating these little NURB circles, and in Blender, it's like these little locators. And the reason why it's a little bit more advanced is you'll start building things like reverse foot controllers, things like that, and you can attach movement or key movement to these circles or these controllers, and you can do things like foot rolls and stuff like that. Now, the reason why I also am bringing up both of these models is the export process actually has an additional feature that you need to do, or an additional step rather, if you're going with something like this. So before I show the export process, I'm gonna touch on briefly one quick point, which is if you are using Blender, we do have a plugin for Blender that will help to export out your character with the rig, which is created by Star Shaw, phenomenal technical artist. But wherever this video is posted, we'll find the details section and I'll post a link to it. So you can also, if you type in O3DE Blender exporter, it was like the second or third pop-up that I found online when I was doing a search. So back to this. So there's a couple different ways of exporting it. So if we're looking at the simple motion, you can just use the generic export settings, which is just go to File and then Export Selection. I'm gonna click the Options box, which is this little box that's to the right of the word. And within this, you can set, you can look at just the selection options or the export options. They're also available if you just click the name, File, Export All, or Export Selection, and you change it to FBX here, you can see those, a more detailed view of those same options appears on the right. So there's a couple things you need to do. One, my animation here, I did a very basic 1 to 24 frame animation. So off to the side here, you want to turn on bake animation. Now baking animation will actually take the animation data and bake it on almost every single one of the keys. You can also bake animation data into the vertexes of your mesh, depending on your workflow. So anyway, you can set it here. You can see it's set to 1 to 200 because my initial setting in Maya, or the path was 200. So you would type 24 here. And the only other option you really need to do here is embed media, which is check this on. And that'll embed the texture data information into the FBX file. There's also, what I love is now notice this only has one key or one animation, which is a walk. There's this other game exporter that Maya has built into it, which is pretty awesome. And what this does is it allows you to segment or compartmentalize your animations, because there's two kind of ways of doing animations. Some people will actually animate everything on the same timeline. So like 1 to 24 will be a walk, 24 to 48 could be an idle state animation, and then so on, jump on the same timeline. So what you could do with the game exporter here is on the model section, you would just give it a path, which you would select, like whether it's the O3D pathing, and then you'd give it a file name. And then within here, you can create these different animation clips. So right off the bat, I can name this clip walk, and then I can say that's 1 to 24, and then from here, 24 to 48, and so on. And then you can keep clicking additional animations and export it out this way. And what's nice about this is it has a lot of the default settings that are there. It's always given me extremely good results when I'm doing that method where I animate everything on the same timeline. Now, the difference between this and if you have a more advanced rig. Now, the reason I bring this up is because it's error prone when you do the other method and you don't take control of the baking the keys yourself. Because what happens is, say you have like a really advanced rig with blend shapes and it's talking and you have a character jumping and there's all that foot roll built into it. What you want to do is you want to select you have your animations here. So I normally will do the same thing. Notice they're all in the same timeline like I mentioned before. So here's a run animation that I did. The character's leaning. These are all the different animations that you'd pull down from Mixamo, right? There's like a whack and like, you know, it's... So after you've broken it all down and you want to export it out, what you have to do to get that data, or you're going to have errors, is you have to hand bake all this stuff in. So what I generally do is I'll select that root, and I use a mel command called select-high, or you can just select the entire model. Now this particular model, before, you can see that my animation keys were keyed on these NURB controllers. If I was to export this out now, I would be losing things like the foot roll and stuff. So what you want to do is you want to select the entire rig. Actually, did I bake it out on both? No, this one doesn't have it. So you can see here's the animation on these, but if I select the root here, it does not have the animation. Well, I think when I was reviewing it, I actually baked it out on both. But ideally, you would not have it baked on both keys. But the way you do it is you select your entire rig, and then you switch to animation, you go to key, and then within key, you go to bake simulation, and here you can just leave it as is, and you want to bake the entire timeline. Now, if you have any, like, this is great if you're doing anything with cloth or fur or hair that you don't want additional superfluous data, you can bake it out this way, export it to O3D, and you'll have all of that stuff in there. So, so pretty phenomenal. So those are two different ways of doing it, and I've always got really good results for both. Now, what we're going to do is we're going to jump into O3D itself. We're going to create a new level, and we're going to take a look at importing in models, or different ways of importing in models. So we have our scene. This was our the test scene that we had created earlier that you saw in the video, where our character's moving and stuff. So we have a lot of the stuff already inside the project that we imported in, but I'm going to go to File, go to New Level, and then we'll just call this like level maybe underscore live, because we're doing the live demo here. And then, ooh, we already have one. Let's do new level. Let's call this level, I don't know, we'll do 0, 1. There we go, okay. Ooh. All right, so a couple of things about the, there we go, there we go, okay. Actually, I'm gonna go ahead and close my editor here so we can.
That's fine, that's good.
Yeah, we'll go through it. All right, so a couple things for those of you who aren't familiar with the editor itself, or is you're usually defaulted to an entity outliner, your asset browser, and then your entity inspector here. So as you select things like entities in your scene, so I'll kind of expand this. This is a shader ball that I usually delete out anyway for, it kind of takes up a little bit of view when I'm bringing in a character. But up in the top corner, your entity outliner has a list of all the assets you'd find in your scene. Your asset browser is sort of where you're containing or you're saving all of your assets for your, that you will eventually bring in. So let's take a look at like bringing in our YBot model. So under actors here, if you pulled it down from the repo, you'll find that this is our YBot model. If you have your own model, you can sort of pull it in wherever you want. But the way that you would bring in models is inside of here, what I generally do is, whether it's in assets or in the project itself, I usually go to Open in Explorer. And really, it's as simple as creating a new folder, whatever you want your folder name to be. So this could be like, you know, YBot02 character. And then within that folder, just dragging in the model itself. So, and then that'll set it up for, you know, it'll trigger the asset processor and bring in the model. Mm-hmm. So let's assume that we already did that, and then this is our model here. So I'm going to go ahead and delete this shader ball out. And then within this, I'm going to just sort of drag it up into our entity outliner and place it in the scene. Now, normally what happens is our models are either too high or too low above the grid, depending on where you initially clicked. So I'm going to hit the R key, and it'll reset the position to the center of the world. Now, I hit Z to zoom in on this character. Now, by default, within our entity inspector, which is a collection, it shows a collection of different components. So we have a transform component here, which shows the positioning or the placement of our object or our character in the scene. Now we have an actor, and the reason why we know this is an actor is because not only because it added this component, but an actor in O3D is any object or mesh that has one or more bones skinned to it. So here's our actor. It automatically added it on there for us. Now, say we'd like to test, so say you're the designer or the programmer and you want to test the animations that came in from your animation editor, or from your animator rather. What you can do is you can add a component called the simple motion component here. And on this simple motion, we have a couple different things. We have the motion that we'd like to test, where we want to preview an editor, and then a bunch of these other options like looping it, if we want to retarget it from another model, reversing the motion. So let's say we want to test our run, for example, to see if it works or how good it looks in editor. Well, we can just scroll down, find our run, drop it into this motion section, or you can actually click this folder here and it'll open up. Generally, it opens to where it needs to be, depending on its connection to the model. So let's say we grab this one here and then we click on preview and editor, and now you can see, okay, it's working pretty good. If we want to loop the motion to see how it looks, you can see it's looping over and over again to test it. If we want to see how the skeleton or other elements react or behave, we can go back to our actor component and click draw skeleton, and we can see how our skeleton works on the model. So let's go ahead and take a look at the next phase, which is like, all right, we're happy, we've seen our animations. Let's set up our animation graph. So let me refer back to my PowerPoint, make sure that we didn't miss anything important. And talked about the actor component, looks pretty good. Now, I'm going to come back to this for a second, animation blending, after I talk a little bit about the graph editor. So inside of our actor here, we can open up our animation editor in a couple different ways. Now, mind you, the animation editor is where we create those state machines I talked about earlier, where we're triggering between animations based on an event. And you can think of an event as like a key press or, you know, anything of the sort. So you can click this little open an animation editor button here, or you can click at the top here on our timeline, or top toolbar rather, and it'll open up the animation editor. My preferred method is opening it directly from the actor, because generally what happens is it loads your actor directly into your scene for you, saving you time. Now, this here, what's really nice about this is you not only have a host of like different options here. Sorry, let me kind of dock this right so we can. You have up at the top here a drop down. Looks like there's a little bit of flickering.
Yeah, it's acting weird.
Yeah, so you have your actual animation. Let's see, maybe let's close that up.
Can you close that? Maybe minimize the editor. Yeah, minimize this.
Okay.
Yeah, try this and go back to the animation editor.
Okay. Oh, it's just kind of sorting between.
Yeah, some Z fighting, I think.
Okay.
Yeah, try to minimize the new one and then, yeah.
And bring this one.
Actually, doesn't work. Okay, go back to the animation. Yeah, maximize that. Try this.
There we go. Okay, looks a little bit of sorting. Yeah, it's working. So, so up in the right-hand corner, we can switch between different views that allow us to focus on the different aspects within the animation graph. So for example, you can see here's a hierarchy of skeletal joints. If we go to character, there's physics. So let's kind of pull this out a little bit so you can see some of those attributes. So really anything that deals with physics, for instance, ragdoll, all this other good stuff, cloth colliders. So let's just go back to animation graph for the sake of time. Now the animation graph consists of a couple of different windows. We have our time view here where we can watch or play our animation. We have our actor manager here, which is really good when we start talking about motion extraction and root motion. But for now, let's just start off by kind of bringing in a motion set so we can see how this other stuff works. Because unless we're seeing an animation really working, we're not getting a comprehensive view of the editor. So right at the top of our motion set, now you can think of this motion editor or motion set manager as you're creating a sort of like a container for all of our animations. So here you can see right off the bat we have one that just says default. So I'm just going to go ahead and rename this one to ybot underscore like mset. So this is the name of the container for animations. And then down here, when I click our little folder icon for adding the different motions within it, we can go in and we can just grab all of the animations that we'd like to see or add to this set. So since we're going to be creating a blend shape that sort of moves with our WASD key to make our character walk around, we're really just grabbing anything that has to do with locomotion in here. So what you can do, and if we look at our time view now, down at the bottom, if I double click one of these, like right strafe for example, you can see it's playing in the timer, I can play it, there's a lot of scrub, we can scrub through. Now, by default, you're actually not going to be, your camera's not going to be following the character. So if I press play, you're going to see our character run off screen. So one of the first things you want to do within this is make sure that you have follow camera on, and then you could switch between these different views, front, top, you reset the camera to the initial view. And now when we press play, you can see that it follows it along. You can try these different animations out here. Before I pass it over to Roman, who's going to talk a little bit more about the animation graph, I want to talk a little bit about how transitioning or blending between animations work. Now, the animation graph is where we would create a series of nodes to blend between various animations, but there's really three concepts that we really want to think about before we get into actually how to blend them. It's like why we'd blend them rather. So you can see here there's this concept of transition blending. So we have a walk to a run, and we just want to transition between the two animations or their movement. And then there's the concept of composition blending. Now you're actually creating a completely new animation when you're taking two different animations, for example, the walk and run, and when you're compositing or blending them together based on weighting, you have this kind of half walk, half run animation that happens, which we're going to kind of get into, and we're talking about animation synchronization as well and how to make that look smoothly. And then there's the last blending option, which is additive. And you'll see this a lot in games. So for example, like you're not necessarily blending between two animations, you're remapping animations for the top part of the body. So this could be shooting, but like the legs are running. So if I kind of come back to that project I was talking about where it was the PTSD game that we're doing for the Detroit police. Now when they're wearing the HoloLens headset and they're talking to these different characters, which triggers different animations, there are certain scenarios where the character will actually turn and look at the character, or look at the actual police officer who's walking in the room. This is an example of additive blending, where we'll mix and match animations to give this sense or this idea that the character is actually thinking. So I'm going to pass it over to you, Roman,
Okay.
now, so
Cool.
you can
Thank you.
show them how to.
Thank you, Alex.
Yeah.
That's a very good presentation. So yeah, I'm gonna basically do a tutorial about how to create Animgraph. I'm actually gonna make 2 versions of Animgraph. So we're gonna make a simple one, just transitioning this guy from idle to walk and run. So yeah, let's do that. When you create this Animgraph, it's first gonna open you a new Animgraph, and this is gonna be a root state machine. So state machine is basically where we do the transition blending. So first, let's create a thing. It's like let's create another state machine. We'll just name this idle or idling. And inside of it, we'll just create a motion node. Motion node. And we call this idle. Actually, not this one. This one. We'll delete this one. We don't need the entry node, actually. We'll just use this one as the entry node. We'll call this idle. And we can select motion here. In here, we just select one idle animation, but you can actually select multiple animation and let it randomly play based on the probability you select. But right now, we just use the one idle. And then you can connect this to the exit node. And now we try play the animation. And you can see it's playing idling. So before we go there, we can actually, this is some of the debug options. We have the root motion debug option now, the line skeleton now, solid skeleton. For now, I think we just keep the line skeleton and the root motion is on. So now let's create a local motion blend tree. Let's create a blend tree. And we call this local motion. It's just short for local. What we want to do is we want to transition from the idle state to local motion state and transition back based on a parameters. So let's work on the local motion first. So let's go inside of it and let's create 2 motion. One is the walk animation, and we'll import the walking in here, and we'll put the running in here. Oh, actually, motion no. Basically, we want to blend this walking and run animation. Run, okay, good. Inside the blend tree. Connect the input pose. Actually, to blend these 2 together, we also need a separate node called blend node. Now in here, we have different kind of blend node. We can use in this case, we only blend 2 animations together, so we can use the blend 2 node. You can also use the blend n node, which support blending multiple motions. Yeah, let's try this. Let's just use the blend n node for now. You can just say run going to walk going to position 0, run going to position 1, and then we can connect the output pose to the final node. The other thing we want to make sure is that we want to go back to look at our working animation and run animation. So this one is already set up because we already turned on the extract root motion option. But if we turn it out, this is going to be the default what it looked like when you first importing the mix and mode animation or like some keyed animation you find online to O3DE. When you play it, it's gonna go over some distance and snap back to the origin. This is because the root motion is not baked in the animation. So there's multiple ways you can fix this. One, you can go back to the DCC tool like Maya or Blender and actually key those root motion so the root actually follows the character. Or with a new way, we can do this inside O3DE. In the inspector, we have an option that says extract root motion, and you can just say turn this on. And you can select the sample joint. Its default will select either the pelvis joint or the hip joint. In this case, already select the hip joint, so that's pretty good. Since this animation is just working in the straight line, we don't need to turn the rotation extraction. So we can just save this, and it will reload the animation. And when you play it, it's gonna move with the characters.
And what's cool, do you mind if I add one thing?
Sure, yeah.
Roman. So if you ever played a game and it looks like the feet are sliding, right? Like they're moving the controller, and the programmer has to programmatically like move the character and say like, okay, I want it to move on the horizontal axis 5 degrees. That's the previous motion. With root motion, the animator is actually like fluidly moving the character, and it's using the actual animation data in the file itself to move it.
Yeah, we call it the data-driven method versus the code-driven method. So we're now using enable the data-driven method. Basically, like the animator will control the distance of the character running, so we will avoid those like full sliding issues. Right. Another thing is that you can go into the actor manager, actually set the motion extraction joint. So in this case, we already set it to the root node, but if I unselect this, it will actually tell you in the inspector window too that no node has been selected. So the runtime motion extraction algorithm won't be running because there's no node select for the motion extraction joint. You can just click like find the best match. Normally, you'll just find the root node for you. Okay, we just need to do that for like the other animation. I think we already did for the running, and then for the turning too. Let's just do it for now, and then you can just do this, and then don't forget to enable the rotation extraction because in the animation, the character is actually turning. So yeah, let's definitely enable there. Okay, let's just make sure they all have that turned on. Okay, looks good. Okay, now let's go back for our animation. Actually, a quick way to test this is that we can go to our root state machine, and we can set this as the entry state. And then now if you play this, you'll actually play the working animation. Now this looks good, but it's not actually blending between animation because we're missing a parameter that's driving the weight value on the blend end node. So now let's do that. So now let's create a new parameter called speed value. And we can just leave the default range of the value on, like the minimum is 0, 0, maximum is 1. We can just leave that as a default. Let's do that. Once you create a parameter, you need to create a parameter node inside the graph. Parameter node, okay, here. And it will already include the parameter you created. So now you have to connect this to the weight value. And in here, you need to select the blend weight mode. I think evenly distribute is pretty fair. So let's select that. And now when you drag the speed value in here, you can actually see this two animation blending. See, when you play 1, it's going to play the running. You select the 0, it's going to play the walking. And when you put them in between, it's going to play a blending between the two animations. This is actually the way to control the blending. So right now you can see, I don't know if that's too visible from like people on the stream, but the foot is like actually pretty bad. Look like there's full sliding going on. So the one way you can fix this is to change the sync mode. By default, it's disabled, but you can actually change to the event track base. Basically, this will try to sync two animations that play at a different. So like you try to sync the left foot touch the ground and right foot touching the ground to try to sync that two event, and the result you're getting is like a perfect animation.
Yeah, because sometimes animators don't know they just want to make the most beautiful animation they can. So they don't know that you necessarily should use the same timeline. So you say you have two animators working on the same team and one animates something at 30 frames per second, someone else is doing it at 24, the legs aren't going to sync up. Even though the engine does its best when it's processing the animations to bring it in to make sure that they're synced up on the timeline, that's why you get that skipping. Okay. One of the reasons.
Yeah, now the blend tree works pretty good. We need to go back and fix this so we can transition from idle to locomotion. The way you want to do this is using the transition blending, and you need to set up, we already set up the connection, the transition from idling to local. Now we just need to add a parameter conditions, which the parameter we just created, the speed parameters. So let's do that, select this. So we want to, when the speed is 0, we want the character to actually play at the idling animation. So we want to transition to local when the speed is actually greater than a threshold value. Let's just say, for now, we just say 0.1, no time requirement. Now let's try this. We play this again. Now it's 0, 0, it's playing at idling, and then once we move this more than 0.1, it's gonna move to local animation. Now we need other transition to make sure it can transition back when the speed go back to 0, 0. So let's do that now. Another condition, same speed. We just want to say when it's equal to 0, 0, Same, 0, 0, 0, 0. Okay. Yes, now let's try this. So running and then going back. Okay, running.
Nice.
Okay, yeah. So this is pretty good. So we want to actually now we want to add more animation to it. We want to add the turn, left turn, right turn. So there's two ways we can do this, right? Once you can just keep working on your local motion stuff. You can keep adding more motion in here and try to add more blend. But there's another really good way to do this is using a blend space. So let's go back here and let's just.
Is using a blend space a little bit more like performant, like opposed to having that spider web of 1,000 different nodes?
Yeah,
like
definitely.
Why would you use?
It's definitely greater to like it's a greater way to managing the graph. Like if you go into this way, you end up with like more than 10 nodes. That way you should have one node, right? Okay, let's do this. Oh, did it work? What happened? Something's frozen. Wait, let's go back here. Okay. Is editor frozen? Oh. Should we just restart this, I guess?
I think so, yeah.
Okay, sorry. Let's try to restart.
One of the reasons not to have 15 different applications open at the same time.
Yeah. How do I restart this now? How do you close this Windows 11? Oh, it's actually, I think the UI is somehow locked. We'll just restart editor. I think that's easier.
Yeah.
Do you know how to do this in Windows 11? So like force to close this?
Yeah, and then go ahead and just.
Yeah, let's close the editor, reopen this. Yeah, okay, editor, close this, and task. Okay, where do you open that again?
No, we'll just go to the desktop.
In desktop? Okay.
Yeah.
Here. This one, right? Yeah.
Mm-hmm.
Okay, sorry. That's cool because we're gonna delete the graph and start a new one anyway. So that's we don't.
It did the work for us.
Yeah. Smart. All right. Make sure it's started. Is this running?
Yeah. So just. Let's see.
This one? Okay. Yeah. Let's open this. Okay, at least open. What's the level you open?
Level, I don't think I saved off the other one, but level 01, I think.
Level 01, okay.
You know, when you were showing the slider, there's other types of parameters, right? Like, is there like triggers? Is there like, aside from just using a slider as a parameter blending between two nodes? It's the most optimal for like demoing it, but are there other types of sliders within it?
You mean how to control the parameters? Yeah, there's different, like a spin box, for example, like there's different UI you can choose, like beside from the sliders. I can show you later.
Excellent.
Yeah, let's go. Okay, so you're saying this one live? Okay, cool. Yeah, I didn't save it, but that's fine. We can add it later. Let's go back to here. Re-add our actors. 3D count, wipe out actors, wipe out, cool. Motion sets, open this motion sets.
You've done this before.
Yeah, we've done this before. We've done this 1,000 times. Yeah, make sure they're, this is all saved, so that's fine. Animgraph. Go back. Let's create a new Animgraph. Yeah, now we want to just use the blend 2D, the blend space 2D node to make it work, to include all the local motion. So let's, again, create another blend tree. We still call it local motion, and this will be the entry stick. All right. And inside of the blend end node and the motion node, we're just gonna create one node called blend space 2D. So for the blend space 2D, you basically have two axes. For the x-axis, we can select the move speed. And for the y-axis, we'll select the travel directions. Okay, and here we can import all the animation that we need. Beside the jumping, I don't think we need to do the jumping now. Okay, so we also need to add the parameters. Let's add back the speed parameters. 0 to 1, okay, okay. And now if we also need to connect this to the final node. Okay, now we can see this play, and you can see it actually automatically calculating the blank space graph. Now you can drag the mouse, the left click in the mouse to test it. Like this is when you are idling, this is when you're running, and looks okay. And the only thing that I'm seeing is not perfect is the left turn 90. Left turn 90 is in there. I think that's okay, but I think the right turn 90 is what is missing. So actually, once the system automatically calculates the thing, you can actually change it afterwards. So I think we're going to change the right turn 90 to be down there. So you can actually, let's do that. Right turn 90, try to find it in here, in here. So the left turn 90, since it's 2.26, we're just going to change this to negative 2.26.
And the reason why it's a negative value is, you probably guessed it, like when you're looking at it, you're looking at a Cartesian graph with the y-axis and the x-axis. So that center point, like if you walk across, if you have them like go from idle to walk, that's the 0.
Yeah, that's the 0.
Our
Yeah. There's
graph.
no direction. Yeah, there's no direction changing.
So anything on the inverse of that is the negative or the positive.
Yeah, if you go negative, you can see it's
So if you get that
changing.
weirdness.
Go to left. Yeah, turning right in here. Perfect. Okay. Another thing is that we already fixed this in the other graph. There's a foot thinking issue. We can do the same thing, change it to the event-based, and it will fix it. Okay. So this looks great now, I think. We can go back here, and then we need to just connect the parameters. So we already have the speed parameters. We just need another one called turn directions. Okay. Minimum, maximum, let's just create it to, change it to -1 to 1. So it's easier.
And that target direction parameter on the bottom, what is that referencing up top in the inspector?
Which one?
For the, is it referencing one of these, the target direction parameter that you
Yeah,
made?
it's referencing the travel directions. Yeah,
Oh,
I
okay.
guess I should name it to travel direction. Same thing. You can change the naming later too.
Okay.
Yeah. Yeah, let's go back here. Thank you for bringing that up though. That's pretty good. Let's see here. Now we just, same thing. Let's bring the parameters node in. Yep. Now we can connect this to in our blank space graph. Let's move it so we have space saved for another thing we're gonna do later. Do this. Not okay. Connect this. Connecting that. So now we play and see what's going on. So when we play this, it's actually not playing the running. That's because the range of our parameter is 0 to 1 based. But if you go to blank space, it's actually 0 to 4.35. So they are not in the same range. So there's two ways you can fix this. One way you can fix this is in here, click edit on the speed value and then change it to 4.3. And now if you play that again, it will fix it. It will actually play the running animation. But the bad part about this is that if you change it this way, you have to change your gameplay code when you feed the parameters to the Animgraph from 0 to 1 base to 0 to 4.3 base. So maybe you don't want to do that. There's another way you can fix this, is actually adding a remapper node. I'm going to just do this real quick. And then you can connect the speed to the X input in the remapper node, and then connect the result back to the blank space 2D node. And so actually, let's just fix this, make this back to 0 to 1 base. And in here, in the remapper, you can actually change it to 0 to 4.3 in the output max. So actually remap the value from 0 to 1 to 0 to 4.3.
And can I add something too?
Mm-hmm. Sure, yeah.
So say you're using a controller and you have the thumbstick. A lot of times you're like, okay, you want it to be like just 0.001 off that dead center point on your thumbstick. If you're doing it with a joystick, we're doing WASD. So you might have a -1 to 1 range. So what's nice about the remapper, because remember this is data driven, like the character's information that's running off of that 2D blend space, it's remapping it so it registers off of that. So it's fantastic for, if you're testing out your animation, or you want your game to be movement on the thumbstick too.
Yeah. So since we're gonna, I'll just do this too, real quick. Just as 0 to 1 base. Our turn duration actually -1 to 1, so we're gonna change it to. Let's go back to see the value. That is all right, -2.26 to 2.26. We'll just change it here to -2.26 to 2.26. Okay, this looks good. Okay. We can connect this again. So now we can fix this. Okay, now let's try this. Speed, it's all looking good. Then changing the directions.
Nice.
The character is moving. Other way. Okay, looks pretty good. Another thing I want to add here before I switch back to Alex is that since we're going to use the keyboard to control, and we want to add a smoothing value, because when you use the WASD control key, it's actually jumping from 0 to 1. We want to actually add a smoothing value. So when we actually hit the W key, it's actually not jumping to 1 directly, but actually doing like a smooth curve to the 1 value. So let's try this. There's a node for that already called smoothing node. And you can actually connect the speed to here, and then to here, back to here. And the beautiful thing about this, now watch when I switch from 0 to 1, and watch it here. Actually doing like a curve thing. So it's smoothing out to the 1 value instead of snapping to it. You can actually change the speed. Let's just keep it to like something lower so it's more visual when we go back to adding the control. Okay, let's do the same thing here. Another thing, when you add in the graph, you can actually copy a graph, copy a node, or copy multiple nodes and paste it. So we're going to do that here. Okay, and then it not only will copy the node, it will actually copy the settings in here too. So it's pretty easy when you actually do the graph editing. You do this way. Let's delete this one, connect this to here. Okay, cool. Try it out again. Okay, let's save this graph. Do a save as, and save here. Wipeout, EMotionFX. Just call it wipeout live. You can use this when we're doing the input binding in the main editor. Let's do that. Okay, cool. Okay, now let's go back to the main editor and let's add this to our actor component or Animgraph component. Let's go back. Let me just add actor for you, and then we can switch back to you.
Yeah.
Okay.
Sure.
Yeah. Let's create this entity. I always do it this way. Actor. Let's find our wipeout character. Add it here, and then so since we already created Animgraph, we can just add Animgraph here. We'll just find the Animgraph we just created. It's called wipeout live. We'll find the motion sets. I think it's the wipeout local motion. And let's delete the shader bow. And you can actually attach the camera to the entity, so it's actually going to follow the character around. And then let's also do this. Just lock it so you don't have to. So you're not like editing it by mistake. Cool. Okay. So I think I'm gonna switch back to Alex now. He's gonna teach you how to create input binding and just make this so you can control the character in the O3D level. Okay.
Sure.
Cool. Thank you.
Yeah. So what I might do is I might do my Martha Stewart cooking show thing, and I'll bring up the project that was sort of already kind of put together before this, and then I'll explain sort of the components for the sake of time, right? Like out of respect to time, even though like time doesn't respect anyone. So I'm going to go ahead and open this up really quick. I think it was level 01. Let's see. Bear with me for 1 second as I bring up.
Oh, this one?
Yeah, maybe Tesla. There we go. Okay, let's see if this. All right, so a couple things. Oh, go ahead.
No, go ahead, go ahead.
So as you probably saw, where we had left off was really we just had an actor and we had our animation graph here. So there's two additional components that I'm going to add, and I'm going to show where they're located. But they're both located up top here, where you go to Add Component, and you can type in Input to add this one. And you can see there's a little 1 there that represents that we already have one attached on our character, as well as the script canvas. So let's talk a little bit about input. So the input component itself works in conjunction with our asset editor up here. And this is where you're mapping key events or joystick events, and I'll create an input to show you this, to actual, like our WASD keys or things like that. So there's a couple ways of doing it. Once you add your input component, you can click your Open Asset Editor button here, and it'll open it up here. Now, right off the bat, this would be pretty clean, and you want to create a new input for it. So I'm going to show you two different types of inputs that you can create, and then we'll come back to and how to remove them. So you click the plus here, and again, you can think of an event as essentially you're using something, a key or like a trigger or whatever, and it's playing an animation or firing off a different event in the scene. So when I click this plus, we're creating a new event here. You see we created one called speed or turn direction. Under speed here, we added two keys, a W key, a keyboard event, as well as an S key keyboard event to drive the speed movement, which was on, when we were talking about our Cartesian coordinate stuff, and I'll show you how to connect this in a second. So how did we do that? So right when we create this new event, when I go into the event name, I can name it, let's say we're going to create a joystick event, right? I can name it joystick or whatever you like, depending on, or movement. And then there's these event generators, which are mapped to different types of stuff, the thumbstick itself or an entire controller. So I'd say I want to use a keyboard or entire controller. I can create an input event here and I'll hit OK to lock that in place. And what happens is you can see here we have one new event generator in place, and then it's going to prompt me, well, what kind of input do you want? So for example, like I mentioned up top, you can do a gamepad, gestures, motion, mouse, all this other stuff. So there's a fair amount of different inputs that you can select. So for example, if we do gamepad, you can see gamepad button A, and there's all these different things, as well as the thumbstick movement itself. So it gets pretty finite. You can get pretty, you can drill down to how deep you want to get with that. So for example, if I select keyboard, you can see there's all these different keyboard events here. So creating an event is something as simple as that. And then you can create the value that you want to send. So for example, with I'm going to delete this joystick event for a second so we can look at the speed and turn direction. You can see every time the W key is pressed, we're sending the event value 1 to our animation graph. So, well, how do you do that? So here's our animation graph, like Roman had showed you. We loaded it up, and then it's the same thing. Once we're done with this, we save it off, and then you can actually grab it by clicking here, and we can drill down to the actual keyboard event that we have mapped here. Now, in order to hook up our asset editor, the input events here, to our animation graph, we require something like a script, like a visual script or so on, or Lua. So we're going to be using script canvas. So as mentioned before, you can drill down through here, find your script canvas component. And if we want to create a new script or open up script canvas, there's a couple of ways of doing that. You can see up here at the top, just like we have the animation editor, we have a script canvas button. You can also click over here, and it'll open a script directly into it. Now we have one already made, and it's a pretty simple script. So I'm just going to run you through sort of some of these nodes and what they do and how they map to our input handler in our scene. So we have this onEntity activated node. So once your character's in the scene and you press play, it fires off. And then we're calling two different input handlers. So now the input handler itself, you can see we have these input events. We have one called speed, and we have another one called turn direction. Let's see if I can get this to... I'm going to maximize that for a second so you can see that better. So what we're doing is right when it fires off, we're going up to our input handler up here. We're grabbing our speed event as well as our turn direction here. Now we have this set name parameter. Now remember when I was talking about inside of our input handler over here, we're sending off whenever the W key is pressed or the S, we're sending a 1, or to this event here, kind of see if I can do this without docking it. We're sending this 0 value. So just like Roman had shown you before within the animation graph where we're sending that information, this is where we're actually mapping it to the various event names. And the event here is called speed, And so that's mapped to those speed ones, and then there's turn direction here. So it's actually setting that name parameter, those values. So just for the sake of clarity, remember speed is here and turn direction is here. And if we go back to our animation graph, kind of really pulled this off a little bit here. There we go. Oh, this is the other.
So this is the other one.
Yeah, we have the move speed. Yeah, it opened up the other one. But
You can just change
essentially,
it in the Animgraph later.
yeah, the two names, yeah.
Yeah.
So I can pass it off too if it didn't. So we have a couple different ones. So it's just mapping to those two elements. So
Yeah, it's easy. You can. I think. Yeah. Let me try to. Let's open the correct one, which is created. Try this local motion. Let's try this one. Now I think the name is already fine. Let's double check. Let's go back here and double check. Turn direction, crude, speed. That looks good. Let me make this. So let's try to play and see what it does. Okay.
there we go.
Oh, there we go. You know what? We need to make sure this follows the character. So let's go back to our camera. Yeah, this is what I'm talking about. We need to just drag the camera to the character. Now this actually follows the character. And then we stop. You can see there's smoothing happening. So it's not going to running directly. And stop. Let's turn. Let's turn right. Run back. And let's play turn. This. Then turn like this. Turn like this. Okay, yeah, that's pretty much it. Okay, yeah, this is like the simple local motion control you can have just using the Animgraph and blend space 2D node and some script canvas and input bindings. Okay, cool.
Yeah.
Okay, now let's exit. Okay, I'll go back to you.
Yeah. Let's go back to make sure we've got all of our ducks in order. Yeah, so thank you very much for attending our talk. If you have any questions, thank you.
Thank you. Do you have like live question, live QA or something?
Yeah, I think in the back if the virtual folks have a question.
Okay, cool. Yeah, we have live audience questions. All right, okay.
So if I import animations from...
Hang on one second. We're going to bring the mic so the screen...
Okay, cool. Yeah, that's better. I got here. All right.
Hello?
Yep.
If I import animations from a third-party website like Mixamo, do I ever need to import them into Maya and then export them, or
No.
can I do directly?
You can do it directly, yes.
Okay,
Yeah.
since the extract root motion is already added to O3D, so I can just
Yeah.
okay,
yeah.
move those
So
animations.
any animation you bring from Mixamo, like it does not contain the root motion baked in.
Okay.
You can use O3D with the way I show you in the presentation.
Okay.
You can extract the root motion directly in the motion inspection window.
Okay. Any reason that's not already the default, because it seems pretty useful, like to turn on root motion
There will
extraction?
be reason that you don't want root motion. So like that's the default. That when we bring in the animation from Mixamo, that's the original version, like without any like additional modifier from O3D. Right. So when you actually want to, like, it's not on by default, right? Yeah.
But generally, you want to make sure that you uncheck that in place and that in Mixamo it's moving across the surface.
Yeah.
It'll work better with
When you download it, you need to uncheck the in place when you download it from
Mixamo.
Mixamo, yeah.
Okay. Thank you.
We have a question from the virtual platform. May we see the link to the GitHub repository for this project again?
Okay, yeah, that's a good goal.
And what's good about if you pull down from the GitHub, we have an additional character that we made in-house that has its own custom animations that are animated at 24 frames per second. And many of the stuff that you find online is 30 to 60 frames per second. So it's a good way of playing between learning how to implement different types, especially with animation synchronization, like we were talking about, getting it to map correctly.
One thing I want to point out that when you go to Mixamo, search for the local motion set. So they actually bring all the animation that we're using in our presentation in here. And you don't have to use a wipeout character. You can actually use a different like characters too. Yeah, I think in Mixamo they're sharing the same skeleton. So you should work on any character. Okay?
Hello. I have a question for the how to generalize the animation. For example, like when the character is walking, you assign walking animation. Like a normal people doesn't loop forever, right? It's just you have exactly the same walking style forever. That won't happen. Like we can choose several different walking animation pre-built.
Yeah.
But is there any way to kind of randomize kind of secondary motion when you walk? So each loop you have a little bit difference from the default.
Yeah, that's definitely a great question. We actually have a feature called simulated object, and there is a documentation online you can find in the O3D public doc that basically is exactly doing what you said, like playing secondary like animation using like a physical simulation we write inside of that animation system. But yeah, we just don't have that in our talk today. But there is some like documentation online you can find. Yeah, well, probably when we'll make next year, we'll come back with that as a permission.
So another question is, since you showed the two way of blending compositional and additive, I wonder like if there's another way to, for example, the two animation walking and a jump will have a smooth transition in the middle. Like that middle is automatically generated between the end of walk to the beginning of a jump.
Smooth transition between a walking and jumping. I don't know the best way right off my head.
When you say automatic, are you referencing that depending on environments, the factors within the environment, it'll trigger a blend between two animations? So you can, remember we had that parameter where you're just moving the speed parameter on a floater. You can trigger it through, like a Boolean value. There's a much more complicated system that you can build. So like you'll see sometimes in video games where a character will walk too close to a surface and they'll place their hand on the wall, right? And what's happening is sometimes they'll be snapping the joint to a specific area or playing an animation and the animation finds a trigger area there. So those things are in there. I mean, just like you said, it's outside the purview of the talk that we did, but yeah, we have that. And you can look at it within parameters and triggering and blending animations through those parameters. Okay, so another difficulty is how to do this small operation on minor objects, on small objects. For example, like my hand operate a phone, operate a cup, taking a different small object. So people just automatically handle this, generate this motion. It's really subtle, and a website like Maximo doesn't really have this micro animations. Do you have a suggestion for that? So like if a character walks up and like grabs a door
grab
handle,
something. Yeah, that's pretty hard because people just generate this.
You're saying without getting it online or having an actual animator who creates the motion and then it snaps to the handle as you get closer or something? This would be just all driven program, like through a programmer, right? Yeah, procedure generation or something based on the shape of the small object.
We have an IK system. We have a two-link IK system. Like that's where I would start in using EMotionFX. We're planning to do some like more IK-related work in the future too.
Are you familiar with inverse kinematics or IK, the term?
Yeah.
Yeah. So.
Yeah, that's what I'm talking about. We have a two-link IK, we have a full IK. That's the existing IK system in EMotionFX, and we're looking in the future to have like more IK solution too.
Okay, so currently there's no commercial platform like Maximo to have a lot of options for the small operation, right? Animations.
In Mixamo, I don't think so.
Yeah, I don't know if anything. I mean, it would be nice if there was. It'd be really wonderful, but not that I know of anything. Like you're even saying like the bones kind of to the finite detail where it would simulate real life, right? Yeah, I don't know about anything like that exists. The only thing I think it was like he was referencing is maybe an IK handle that snaps and it gives an impression that we're modeling or simulating real movement, So the short answer, no, I don't know.
Okay, so latest research to have many like generation models like a Ganimator. That's the latest research. Do you think there's a potential application in real game engine for this generation-based animations? Like
generating new animation based on like IK or based on?
Based on one animation, they just try to generalize with, for example, you have one dancing move. They can actually have many similar dancing moves generated.
There's some do you want to tell me about motion matching? You were telling me about it before.
No, that's different. Motion matching is different. It's a different topic. Yeah.
Yeah, but because what you're referring to is blending two or more animations, correct? Like
It's not
Generating new animation.
generating.
Oh,
yeah.
okay.
Yeah, I saw the paper. It's pretty cool. Yeah.
Oh, okay.
But yeah, we don't have any existing solution at least yet in MotionFX right now.
Okay.
But we're definitely interested into that categories for sure.
Yeah. Thank you.
Yeah. Thank
Yeah.
you. Okay. Cool.
Oh,
Curious about, I'm not sure if it's something I missed, but when you created that blend space 2D node, how did it find all the animations and create that map? Just
It's based on, that's why actually the root motion extraction is pretty important because it's all based on the root motion. From the root joint, like the move speed, like it's actually calculating from how long it's moved. It's actually calculating the speed based on the root.
So how did it know that like you had a left turn animation and a right turn? Like it seemed to just
How
magically
do they know
find
the
those.
right turn and left turn?
No, how did it know that? Because you had separate animations for those, right? So
Yeah.
How did it find those and know to map
Well,
them
it's
in?
actually, it's based, there's two axes, right? That's speed and the turn direction. So our animation will have a different value mapped to that.
Okay.
yeah. So I know what you're, because in some other engines, you have to manually drag them in and set them onto a 2D or 4D blend space. Yeah, like what I think is amazing about the 2D blend space system that we have is, like you said, you have that Cartesian graph and there's a 0 point in the center. Your animation has a positioning in space when it's set to root motion. So it automatically, like the best of its ability, like Roman was showing, like it'll map it across that Cartesian system. But like sometimes it's a little off. But it is really smart. Like, I mean, when Roman first showed it to me, I was blown away as an artist. Like, you know, even as a tech artist, I was like, oh, wow, so it's just in there? Like, I don't have to like
Yeah, that's
mess
really
with these things. Yeah, it was so freaking cool. And so,
Just because we have
but he
the
noticed he had to
motion
still
there,
mess with, I'm sorry.
Sorry. Yeah.
I'm just overly excited.
Yeah.
Notice that he had to mess that just a little value a little bit just to make it negative, and then it was like perfectly cool. So I think that's like a really powerful feature. Sorry, go ahead, Roman.
I'm just saying is all the information you need, like the move speed and the turn direction, is already inside the root motion, the movement of the root joint. So it's already in there, so we can calculate it.
And he's the one who, like, this is his baby. Like, this is what he works on. Like,
Sort of, but like, we
I'm giving you all the credit. I'm giving you.
Yeah.
I mean, as part of a team, but
Yeah.
that's,
Part of team. Yeah.
yeah. While we're up here, we should take all the credit for.
Oh yeah.
I'm just joking.
It's our baby.
Yeah.
I guess another question about the blend space 2D is
Okay.
there are some nodes that get created by default in like the middle of the Cartesian plane. So what are those nodes, I guess, or what makes them significant enough that those nodes get created? Because I'm assuming
each node represents a motion, actually.
Okay.
So every node we imported from the motion set actually will represent a dot in there.
Oh, okay.
Yeah.
So you're talking about right on zero, right? In the center of the graph, how the idle, the walk, and the run all magically popped on that center line. Is that what you're referring to?
No, it's not just on the center line, but if you have the x and y axis, there are some nodes between x and y axis that get created. So I assume that the system is automatically calculating them based on some logic, but are those just like motions that already
each
exist?
node will be a motion. Yeah.
I see.
Yeah.
Okay. Thank you.
Any other questions? Maybe online or in the chat?
All right. Thank you all very much for.
Yeah, thank you
attending.
all.
Thanks.